Okay, so today we're going to be looking at tangent lines and rates of change. To start, we're going to just talk about the definition of a tangent line. And geometrically, it's a line in geometry. It's a line that touches a curve at a point without crossing over it. So if this was a parabola here, our tangent line would be this dashed line at the point without crossing over it. And like here, if this was a point, our tangent line at that curve, like this isn't the best sketch of it, but you can see the point. Formally, what we're going to talk about more is it's a line which intersects a differential curve at a point where the slope of the curve equals the slope of the line. Okay, and then next we're going to look at secant lines, a straight line joining 2 points on a function. So if I have this function right here, and follow it through, point P and point Q, this line going through that is going to be your secant line. So, and also if this is an A, and we look over here, this is F evaluated at A, and if I let this be A plus H, so I'll go over the distance H, and this is F evaluated at A plus H. So that's just looking at this particular case. With this sketch in mind, what would be the slope of the secant line PQ? Okay, so let's think about that. How would you normally find slope? So rise over run, or formally if I'm given slope of 2 points, you remember the formula for that? Good, yeah, y2, let's write that down. Okay, good, your formula for slope, or sometimes we just denote that as the change in y over the change in x, right? So formally, we've done that before. So now let's apply what you've known in algebra and to this particular image that we have up here, this graph. What's your y2 value? So it's the change in y over the change in x. What's the change in our y values? F of a plus h minus f of a? Good, so I'm going to just denote this as the slope of secant line PQ is going to be the change in y values over what's next? The change in x, which would be, what's x1 minus x2? I mean x2 minus x1, excuse me. Right? So it's just going to be over h. So now I'm going to ask you, what happens if we choose our points closer and closer together, basically to the point of tangency? So if my point right here, I have point P, and let's say I have point Q, what if I move point Q closer to here? And then I have a new secant line. And what if I move point Q here, and I have a new secant line? And if I move it here, I have a new secant line. Okay, so we would get a more and more accurate approximation of the slope of the tangent line. So basically we can get our secant line to be a better approximation to the curve near the point A in particular. And it's kind of like we're just calculating the limit. Okay, so in that case we're just going to calculate the limit. So you can see the definition of the slope of a tangent line is the slope of the tangent line to the graph of a function f at the point P is the limit as h approaches 0 of this particular function. So it's the limit of f of a plus h minus f of a divided by h as h approaches 0, provided the limit exists. And we say that as h approaches 0. Let me clear this off and move back up. So here's our h value. It's the distance between these 2 points. So we said as we move Q closer to P, that's as h is going to get smaller and smaller. Say I move it here, then my h value is smaller. I move it here, here, here. So that's when I say where it's the idea of taking the limit of our, so that brings us to our definition. So it's the limit of this particular slope as h approaches 0. Alright, so now that we introduced the idea, let's go work a few examples of this. Okay, so I'll give you a minute. Our first function is going to be f of x equals x squared, and we're going to, part A, we're going to find the slope of the tangent line at point P, and part B, we're going to find the equation of a tangent line at point R. Okay, so the first thing we're going to do to find the slope of the tangent line is we use our definition. Slope, the limit of f of a plus h minus f of a over h as h approaches 0. Okay, so we take our formula and we want to evaluate f of a plus h in our function. So if I replace x with a plus h for this particular case, I would get a plus h squared. Okay, and for this, if I evaluate f of x with an a, so if I replace this with an a, I would get minus a squared, and then I just have h. Now, let's go off to the side and FOIL that out, and then come back and put our answer over here. So FOIL this out to the side, and then, okay, and now we're just going to simplify at this point. So our a squares simplify, and it looks like we're going to be left with what do these two have in common? And h. So let's go ahead and factor out an h for those. So we have a 2a plus an h left, it looks like, over an h. And then don't forget as h approaches 0. And then now what do you think happens? Good. The h's will simplify. The h's cancel out. And we're going to be left with, actually, I'm going to put that in blue. Okay, so this is what we're left with. And now evaluate the limit as h approaches 0. So let's actually evaluate the limit, do direct substitution, and what do we get for the slope? Just 2a. Good. So 2a is the slope of the tangent line at the point P. Part B asks us, find an equation of the tangent line at the point R. Okay, here's my point, and here's my slope. I need an equation of the line. What do you think we can use? Point slope form, right? We have a point, we have a slope, so our point slope form. Okay, so that's our point slope form. Let's fill that in. So it's going to be y minus y1. Our slope is going to be 2a. Let's see if we can evaluate that first. Do we know what our a value is in that particular case? Look at point A up here. It tells us your point is a comma a squared. So what is a? -2. Well, we know what that is, so let's evaluate. So if we know a is -2, what is the slope at that particular point? -4, so let's use that as our slope here. -4. And then we have, I should have just done that sooner, but we have x minus, and then our x1 is what, a -2, so that's just going to give us +2. Alright, now we just want to solve this thing for y equals, so we'll have y minus 4. Add 4 to both sides, just simplify this up algebraically. Y is equal to -4x minus 4. Alright, let's recap. This is going to be the equation of the tangent line at the particular point R. And the first thing they asked us to do is to find the slope of the tangent line. So we found that slope to be 2a, but they also gave us the point, in this particular case we knew our a was -2 for part B. So when we knew that, we could actually get a number value for our slope, plug that in, and then we can find the equation of the tangent line.